Okay, so here we are. Let us take a look at those quiz questions from momentum and impulse, two very important concepts. In this question, you have a proton of mass m. It is not moving, and it's struck head-on by an alpha particle, which is two protons and two neutrons, and it's moving at speed v. If the collision is completely elastic, and that's very important, because if it's an elastic collision, we can use an extra formula, an extra equation. What will be the speed of the alpha particle after the collision? It also says the neutron's mass is equal to the proton's mass. So when you go back to the alpha particle and look at it, because it has two protons and two neutrons, well, sorry for that interruption, and I was saying that since the alpha particle has two protons and two neutrons, it's going to have 4 times the mass of a proton. Okay. And so we proceed from there. We know the masses of both. We know the velocity of the alpha particle before the collision, and we have to find the speed of the alpha particle after the collision. All right. So using the principle of conservation of momentum, that is the total final momentum before collision on the left hand side is equal to the total initial momentum after collision. And now take the mass of the proton as m, and the final velocity of the proton is v1 prime. Velocity of the alpha particle is v2 prime, and its mass is 4 times m. So that's the total final momentum is equal to 4mv. Why? Because the proton is initially at rest, and that's why the second term is missing. So this is only the initial momentum of the alpha particle, because the proton has no momentum. Now we can cancel the mass out from all these. And then again, because it's an elastic collision, we can use the formula v1 prime minus v2 prime is negative. Oh no, that I have to change that. It's actually v1 prime minus v2 prime is equal to v2 minus v1. Or when you distribute the negative sign, you get v1 prime minus v2 prime is equal to negative v. And that's because v1 prime is, v1 is 0. The proton is not moving, so this quantity is 0. And this is given as v. So that is why you have that. Now 1 minus 2. So when you subtract 2 from 1, so you get on the left hand side 4v2 prime and then you have minus of minus v2 prime. Okay, we subtract to the left hand side. And surely the v1 primes get cancelled when you subtract one from the other. So you get 4v2 prime minus of minus v2 prime. And on the right side you have 4 times the velocity, again minus velocity. Now remember, two negatives make a positive. So okay. Now that was the mistake that I was making, and I've corrected it now. So here it is now 3 times the velocity, because this velocity is positive. That's the velocity of the alpha particle before collision. Okay. Which we have taken to be V2 is given the value V. Okay. So V2 prime is 3 by 5. So that's how you get the answer. You have to be very careful about not mixing up between the terms. So again, in this question we have called 1 the proton and 2 the alpha particle. So keep that in mind. In the second question, handball of mass 0.1 kilogram is traveling horizontally at 30 meters per second, strikes a wall and rebounds. Now that term rebounds is very important, because when you see that word rebounds, that means it's moving in the opposite direction. That means this velocity is going to be negative if you consider this to be positive. So if you take 30 to be positive, this is going to be negative. Or if you take 24 to be positive, 30 is negative. The only thing is that both have to be in different directions. So if one is positive, the other is negative. And you're asked to find the change in momentum. The change in momentum is mass times the change in velocity. Mass is 0.10. I'm taking 24 to be positive, so minus 30. So that makes that positive. And so you get 0.10 times 24 plus 30, which is 54. And when you multiply, you get 5.4 kilogram meter per second, which is the proper unit for momentum. In this question, you have two objects moving on a level frictionless surface. Object A moves east with a momentum of 24. Object B moves north with a momentum 10. They make a perfectly inelastic collision. Now that is the most important word there. If it is a perfectly inelastic collision, that means they stick together, which means they have the same final velocity. So they stick together. That means V1 prime is going to be equal to V2 prime. And you have to find the magnitude of their combined momentum after the collision. Magnitude means just the size. How much of the combined momentum after collision? Don't we know that the collision before should be equal to the total collision after? So to find the momentum after the collision, it's enough to find the momentum before the collision, because they're equal. So that's what I'm going to do. So you have the two objects A and B. That one is moving east at 24. That's its momentum, 24, and the one to the north, 10. Now to find the resultant, all you got to do is square both up, add them, and take the square root. This is going to be the total momentum before the collision. So actually we're getting the total momentum before the collision. But remember that the total momentum before and the total momentum after are equal. So whatever we got, which is 26 kilogram meter per second, is both the combined momentum before as well as the combined momentum after. In this question, you have a 1500 kilogram car traveling at 90 kilometer per hour east, colliding with a 3000 kilogram car traveling at 60 kilometer per hour south. The diagram is given. The two cars stick together after the collision, means it's perfectly inelastic, and you're asked to find the direction of motion of the cars after collision, which is theta. Now to find theta here, what you got to do is you got to consider that the triangle is completed, and if you see the triangle as a completed one, definitely you're going to see this momentum you're going to see this here. Let me use this. Okay, you have a component here, and you already have one here. Okay, another one here, kind of. Let me draw that. Oh, so you have a horizontal and a vertical there, and what you got to do is to find tan theta. It's going to be the opposite side, which is this side, opposite side here, by the adjacent side. So the opposite side by the adjacent side. Okay, the momentum along the x is 3000 times 60, because momentum is mass times velocity. Which gives 18 times 10 to the 4. And you know the unit is kilogram times kilometer per hour. That's actually py, sorry. And then px is 1500 times 90. That's px. So you got 135 times 10 to the 3, again the same units. And to find tan theta, you take py by px, which gives theta is tan inverse 1.33. So that's 53.1 degrees. And the angle is to the south of east. Yes. And in the fifth question, a 0.1 kilogram object with a velocity of 0.20 meter per second in the positive x direction makes a head-on elastic collision. Okay, the important word, elastic collision, with a 0.15 kilogram object initially at rest. What is the final velocity of the 0.10 kilogram object after the collision? So you get your M1s and V1s identified, and they use the principle of conservation of momentum, which is M1 V1 prime plus M2 V2 prime is M1 V1 plus M2 V2. So our one is the 0.10 kilogram object, and the other one has 0.15. We do not know their final velocities, so V1 prime and V2 prime both are unknown. And since the second object is initially at rest, that is why this term becomes 0, because the velocity is 0. Okay. So that's our equation 1, and because it's an elastic collision, we can use this equation like we did before. And once again, remember that V2 is 0 here, so there's nothing there. That's why you have negative V1. Now, to solve this equation, what I did is multiply equation 2 with 0.10. So, because then I see that these two terms will become equal, and so if I subtract one from the other, they're going to get cancelled. So 1 minus 2. And here you see, actually you'll have to multiply this with this, and then there's 0.15 minus of minus 0.10. That's why it's plus 0.25 gives 0.04. So V2 prime is 0.04 by 0.25, which is 0.16 meter per second. Now substitute that into this equation, and we can find V1 prime. You get it as negative 0.040 meter per second, means it's moving in the opposite direction. In the sixth one, there is a 20 kilogram mass moving at 5 meter per second, collides head-on with a 3 kilogram mass at rest. If the collision is perfectly inelastic, now inelastic means they stick together after the collision. They have the same velocity. Keep that in mind. So v1 prime is equal to v2 prime. That's the equation for conservation of momentum. Mass is 2, speed is 5. And the second one is at rest. That's why the second term is 0. And then after collision, they have the same velocity. So add their masses and find the velocity. Now, both v1 prime and v2 prime are equal, so I just call it v prime. So that gives 10 divided by 5, which is 2 meters per second. Here, a ball of mass 0.10 kilogram is dropped from a height of 12 meters. And we have to find its momentum when it strikes the ground. Momentum is the product of mass and velocity. We do not have the velocity when it's at a height, but we do know that the potential energy at the top becomes exactly equal to the kinetic energy just before it strikes the ground. So we can use the energy conservation principle to find the velocity and then use that velocity to find the momentum. So potential energy at the top is equal to kinetic energy at the bottom. Potential energy is mgh. It's equal to 1/2 mv squared. Square root 2gh. That is 15.3 meters per second. So momentum is 0.10 times 15.3, which is 1.53 kilogram meter per second. So that is the momentum. In this next question, you have a 0.10 kilogram ball dropped on a tabletop, and the speeds of the ball right before and right after hitting are 5 and 4. See, although the numbers are 5 and 4, you have to remember that the ball, once it hits the tabletop, is going to bounce back. So, got to take one of these velocities as negative. You can either take 5 positive and 4 as negative, or the other way around. If the collision between the ball and the tabletop is 0.15 seconds, what is the magnitude of the average force? So we can use the formula for impulse. Put them both together. Impulse is either the product of force and time, or it is equal to change in momentum. So the time of contact is 0.15. Now that's where we have to be careful. So it's not 4, it's negative 4. Why? Because it's going back in the opposite direction. So 2 negatives make a positive, it becomes 9. And therefore force is simply 0.90 divided by 0.15, which is 6 newtons. Here the two astronauts have masses 60 and 80 kilogram. Initially at rest, they push each other. What is their separation after the lighter astronaut has moved 12 meters? See, the lighter one will move a bigger distance than the heavier one, and it depends on the ratio of their masses. The idea is that the center of mass must be fixed. The center of mass does not move. So, taking the ratio of their masses to the inverse ratio of the distances they move, x by 12, you get x as Oh no. Actually, what you get here is 9 meter. I'm thinking too fast. And so one has moved 12, the other has moved 9. Therefore, the total separation between them is definitely 12 plus 9. That's what gives us 21 meters. So now they are now 21 meters apart. The fire hose is turned on the door of a burning building in order to knock the door down. This requires a force of 1000 newtons. The hose delivers 40 kilograms per second. Look at that unit. It's not just mass, it's mass in 1 second. What is the minimum velocity of the stream needed, assuming that the water does not bounce back? Now, if the water does not bounce back, that means its final velocity is 0. Okay. So to find the force is given by mass times change in velocity divided by time. Now, mass by time is given. That's 40 kilograms per second. So it's mass by time. Therefore, all we got to do is multiply 40 with the final velocity, remember, is 0 because water doesn't bounce back, minus the initial velocity. So when we carefully calculate that, you get VI as 1000 divided by 40 with a negative, because that is negative 25 meter per second. That negative just shows the direction that it was first going towards the door, and that's all. That's the importance of the negative sign. This one is a direct question. What is the momentum of a 2000 kilogram truck traveling at 35 meter per second? Momentum is just the product of mass and velocity. Multiply the two numbers because they're already in their proper units. And you get 7 times 10 to the 4 kilogram meter per second. Here in number 12, you have a car of mass 1000 kilogram moving to the right at 6 meter per second. It collides directly with a stopped motorcycle. So that second object, the motorcycle, is at rest. It has a mass 200 kilogram. What's the total momentum? Again, after the collision. We need not worry about that word after, because we know that the momentum before and the momentum after are equal. So all we need to do is find the momentum before. And that's m1v1 plus m2v2. Which is 1000 times the speed, which is 6, plus the other one is not moving. So it's 6000 kilogram meter per second. That's the total momentum before. But the total momentum before and after are equal. Therefore, this is going to be the total momentum after the collision. And the direction is going to be to the right. Here, the machine gun, the mass is given, 35 kilograms, fires 50-gram bullets with a muzzle velocity, that is just the velocity with which it comes out, 750 meter per second at the rate of 300 rounds per minute. So we got to find the force. Although the mass of one bullet is only 50 grams, there are 300 rounds fired. So we have to find the total mass by multiplying 300 with 50 gram after changing it into kilograms. And use the formula for force as we did before. Let's find the mass now. Mass is, and actually here the mass of the machine gun doesn't matter at all. That's just extra information. So when you multiply it, you get 15 kilograms, but that has to be divided by 60 because it's per minute. You need to change it into seconds. And initially the bullets are not moving. That's why the initial velocity is 0 there. And then when they come out, it's 750. So 188 newtons have to be applied on the machine gun. Here in the next one, a constant 9 Newton force acts for 2 seconds on a 6 kilogram object. What is the object's change of velocity? Direct question. Use the two equations. For impulse, force multiplied by time. Both force and time are given. Mass is 6 kilograms. And the initial velocity is 0. But we are asked to find the object's change. And Vf minus Vi is just the change in velocity. So that's what we're looking for. Divide both sides by 6. And you would get the change in velocity as 3 meters per second. That is the change in velocity. Here a 2 kilogram mass moves with 5 meters per second, collides with a 3 kilogram mass at rest. If the collision is perfectly inelastic, what is the speed of the masses? Okay, this is a repeated question, so I will just go through this fast and give it to you in one instant. I had done this. It's a mistake that I repeated it again. So here it is. 2 meters per second. We got this before. And in this question, a 4 Newton force acts for 3 seconds, and then the force suddenly increases to 15 newtons and acts for 1 more second. What's the impulse? Find the impulse due to each one and add them up, because impulse is the product of force and time. So the first force would give you 4 times 3, 12. Second one gives you 15 times 1, which is 15. Add 12 and 15 to get 27 Newton second as the total impulse. Well, remember that in this chapter, momentum is the product of mass and velocity. Conservation of momentum. Total momentum before is equal to total momentum after. For impulse, there are two equations. Put them both together. And then if it says it's an elastic collision, we can use this equation where we take the difference in velocities after collision is equal to negative of the difference in velocities before. Okay, so those are the equations. I hope you understood all of these problems. Thank you.